this event. Can you do it to the other slide, please? You didn't do the command. Oh, I think present in the upper right. It's not touched on. So we're collecting this information so that way we can go back up one slide. So we can have this event. It's roughly going to be in 2 months, but we're collecting everybody's information, and then we're collecting all the people who are hiring. We're going to have a speed dating event, so that way we can see if you're dateable. And anybody here remember the being pushed to the wait list or anything like that in previous events? I didn't have that problem today, especially with a week and a half. So in previous events, I was predicting attendance, and if you go back up again, I've got control here, I don't. Okay. We're going to use that same algorithm to determine who actually gets to go into the event, right? So if you need roughly 2-to-1 ratio of companies to candidates, right? So we're going to use that algorithm in order to determine who is the best candidate from our network to be seen with those companies. So, and of course, we have 13,000 data scientists who hopefully we can choose from. And that's what this algorithm is for, if you remember it. It's all about who comes to the events, who is most connected between the groups, between the topics, and how many events that you've actually attended. So it's about clustering people in terms of their involvement and their activity in the network. That's how things are prioritized. And I'm going to skip over that one for right now, but if you ever are looking for a venue to host something, you can just go here to venues.datacommunitydc.org, and we've collected all the different venues that we have good relationships with, and we'll help to connect you. And we do this stuff at Brunch and Hacks, which I organize on every first and third Saturday of the month. And of course, there's a special thank you to our sponsors. If I'm going to turn this over to our guy who knows how to make data great.
Anyway, thank you for all coming out tonight. This is a great venue, isn't it? Isn't this venue so great? This venue is amazing. I really want to thank our sponsors from Capital One tonight for making this all possible at the last minute. We will make sure that we make data great again with your help. So, we want to first off with a round of more applause for Capital One. But we also want to thank Bruce Allen, because you know, they're great, you work for them, you'll be great, you'll make data great again. Then, AOL.com. We take America online, we're going to make America online great again. And then statistics.com. Because you know, math is good, stats are better. I don't know. And then deep learning analytics. If you guys get the time to look up the Donald Trump tweet, they actually developed a machine that tweeted like Donald Trump. So deep learning, making America great again. So we also have to thank statistics.com for offering 15% off all courses. The courses are not going to be 15% off. So statistics.com, just use the code DC2 and click on the link in the PowerPoint. We will email it out after the presentation. Make America and data great again.
Hey, so I'm Jackie from Capital One. Thank you for coming out tonight, and I just wanted to add that, of course, we're hiring. There's a couple of jobs open, everything from data science tooling to data science itself. So if you're interested, please come and find me afterwards.
Any other announcements? You can raise your hands up.
Women Data Scientist DC is having a meetup on Sunday. It's Data Projects Meetup. Come join us if you work.
Hi everyone. I'm part of Graphicacy, who I think at the last meetup, Nathaniel Perlman was a speaker, launched a contest called Major League Data Contest. It's currently in the process of ongoing. There is still time to, and that's it. Excellent.
I got you covered. We didn't even talk about it.
That's brilliant. There's still time to submit entries for this. Due April 11th. The prize is $1,000. Fantastic lineup of judges, including folks like Richard Tallman, who's the founder of the TED conference series, etc. So just a great opportunity to get your work out in front of great distinguished judges, and also a nice prize award as well. And we'll be, I understand, we'll be announcing the award winners at the upcoming event.
Yeah, that's the idea. So we're going to have the next DataViz. Hopefully, we'll be here if you'll have us. If we have this wonderful space, we'll actually fill it completely. Huge. It'll be huge. And we'll announce and we're going to get a big check. One of those really big checks, and that's what we're going to give to the winner. So, any other announcements?
Hey, I'm David Lochevo. I am CTO of Web Finance. We educate and entertain 60 million people in business finance and investing. Skip the whole recruiting thing. Talk directly to me. It's a crossover between data and web development. Give me a talk.
And I want to start a project that looks at product data and metadata, so including review data. And I want to do analysis on it and visualizations on it. So if you're interested in that sphere, come talk to me afterwards.
Yes.
Okay. Hi everyone, my name is Mim Liu. I am with a company called Stack Builder. If you are interested in big data, Tableau, hosting anything on Mongo, and want to know how to spin off those environments in less than 15 minutes in a very secure way, come talk to me.
So SciPy submissions for anyone who does science in Python are due on Friday. You should go check out the website. It's in Austin this year, again.
And if you're not sure where to go, just message me and I'll forward you to her.
Hello, my name is Casey. I'm actually speaking on behalf as an agent for my girlfriend who's getting a PhD in stats. And during the summer, they usually do an internship for like 2 months or so. So if you're looking to hire somebody just for that time frame, with this echo, it's messing with my head. She's an expert in R and SAS, and she does some techniques called propensity score matching and assessment and measurements and a number of other things. I have business cards. If you're interested, come talk to me back. Thanks.
Is that it? Oh, yeah.
I'm Robert Gove, and I'll jump on this career bandwagon. So I work at Invincia Labs. We're an R&D cybersecurity company in Arlington, in the Ralston Metro Station. And our data science team is hiring. We're looking for people to do data visualization and data science, build machine learning models to help build more secure cyber infrastructure and help build tools to enable cybersecurity analysts, malware analysts to help them keep their network secure. So if you're looking for a job, please come talk to me.
I'm just going to hop on that bandwagon and say that this is the basic format that we've had for the past 4 years or something like that. And what we found is that the person that may be perfect for you is going to come to the next event or came to the previous one. And we haven't formally been organizing this stuff. So that's why if you didn't click the button, if you didn't have a chance to talk to Tom, give them all your information, because we're collecting from all 8 of our programs. And across Data Community DC, we reach about 700 data practitioners. I just decided to make up that term. I think it makes sense. Data practitioner instead of data scientist, because that's very specific. We have 700 who we reach a month. 250 of them are new. 200 of them are core people that come to the events regularly. And so that is the best way to get engaged in this network right now. That's why we're doing Datable. Any other announcements? So, by the way, I don't know if anybody who here contributed to Data Society. I did. We got 2, 3, 4. Excellent. So they were successful. They raised over what, 36,000, I think, or was it 37? It was at least, and their goal was 25. So thank you very much. And we just talked about that $1,000 gift prize. And so you will be announced here. Maybe we'll give you a big check. We just came up with that. I love thinking on the fly. And did we give out the index cards?
Yep, they're all out. Yes, I did that personally.
Excellent. You do have your index cards. So we've been doing this every time. If you write down the story of what is going on tonight, then you take a picture of it, you tweet it to #DataVizDC. We'll show them at the end, and we'll vote on who gets to win. And this was the one from last month that won. This was excellent. She's actually going to end up talking not next month, but the month after. And I love what she put together, the way she thinks. And with that, without further ado, I believe the first one is Kathy. So let's have a big warm round of applause for Kathy.
Awesome, thank you. So my name is Kathy Qian. I run a company here called Ticker Machine, and what we do is we develop analytics for low-frequency algorithmic trading. And when I started this project, what was really interesting to me is that there's a lot of buzz and data visualization about, we're getting a lot of big data. Let's talk about how to make that accessible. And there's so much detail around colors and different types of charts and different charting libraries. I thought it was really interesting to step back and see, well, what did the past look like, and how can that inform design into the future? So what's interesting about financial data is that it's literally been around forever. Right? We have hundreds of years of different formats, and over time, we've gotten more and more data. And so today I want to give a talk about how the changes in different audiences and changes in the amount of data that we do receive has changed the way we visualize financial data over time. So first I want to start off with who issued the first stock. I don't know if you guys remember from history class, but actually it was in 1602 with the Dutch East India Company. So this is when, instead of having a limited liability company, instead of having investors come in and fund one trip or one ship, the Dutch East India Company thought, well, wouldn't it be great if people just funded our entire company and we could share profits? And so the kind of first database you have of stock prices is you just get a sheet of paper, and this sheet of paper will tell you what you owe and how much it cost. So what's fascinating is that actually almost 200 years passes before we figure out what's a good way to trade stocks, right? So in the late 1700s, 24 people get together in New York City under what they called a buttonwood tree, which I Googled, and apparently it's just a sycamore tree. And they got together and decided, wouldn't it be nice if we could trade stocks on behalf of other people? An interesting conundrum at this time is how do you know how much the stock is worth? And where do I find this information? So the second iteration of visualizing data here was that you hire interns. At that time, they were called runners. And they would go and they would literally run from place to place, telling you, holding up a sign, a piece of paper, telling you how much everything was worth. So, that was really a great system. It wasn't accessible to the average person at all. So, what happens next? And as we're talking about it, and I think it through, let's apply this to data we're getting today, right? So we think about things like Internet of Things, we talk about like Fitbit data. Do we see the same kind of patterns happen? So what happens next is the New York price current gets published, and it publishes kind of exactly what you see here and what was published for the next hundreds of years, which is just a ledger of stocks and their current price for today. And what's especially interesting here is that the New York price current wasn't published for a long time. It was actually published only for about 20, 30 years. And then there was kind of this deep void until more mainstream newspapers that you kind of think about today, like the Wall Street Journal, took over in the mid-1800s. Awesome. So what happens next? Well, before we had just data, right? We would transmit it and you see it once a day and it was on a newspaper. What happened next was that the electronic telegram got invented. So suddenly there was a way to see updates in real time, right? So in the late 1800s, there was a system called bucket shops. And they're affectionately called bucket shops because what would happen is that someone from an exchange would essentially send you the price of a stock. And a whole bunch of people would get into a kind of like a schoolhouse like this and essentially deposit their money into buckets. What's interesting is that today you hear a lot of financial fintech startups talk about, you can buy partial shares. Like, this is like a new thing, this is great. This was your first partial share. You bought a partial share by committing your money into a bucket. And so what happened here, right, is let's think about, okay, so first we have just raw data being published, and it wasn't updated on a high frequency. But now what we have is essentially one person who reads the ticker, which essentially the telegram would show you what the price was, and the other person would yell in a situation like this. They were the data biz, and people would bid on the price of the stocks. And this was kind of a terrible system. You were essentially betting against the bucket shop. So if the price of your stock dropped by $1, oftentimes you forfeited your entire investment. Needless to say, they kind of went away and kind of were regulated to death. So the next iteration of data visualization happened then when strictly regulated exchanges came about after the Great Depression. And this is when information started to be shown publicly kind of on vertical display boards. And a rapid of companies were starting to come together with projectors, and brokerages no longer use their interns or runners, and instead would just project information onto a screen. So what I think is particularly interesting about this evolution so far is when we think about things like Twitter data, right, and how it used to be, we would first see like a Twitter feed, and you would only have access to it like in your computer. We had to log in, and over time you get more and more dashboards coming out, and essentially the data is available on a wall, right? And I think that it's fascinating that despite the different types of data, we kind of have the same trajectory of figuring out how to present it. So finally, in 1971, we end up with NASDAQ, and NASDAQ is the first automated quoting system. So finally, we get real-time updates. And NASDAQ was actually really what I consider the beginning of modern day visualization. So what you see here is a small order execution system that was created because in 1987, the stock market crashed. And when people were trying to sell their stocks, essentially brokers would just not pick up the This was not ideal and probably illegal, so we created this system where people could connect to the markets themselves and execute their own trades. But what's interesting, right? I mean, this is 1988, and at this point, we're essentially still looking at lists of numbers. And if you remember, the first list of numbers were essentially published in the 1700s. So 200 years and almost no change, right? We've simply changed from numbers on a newspaper to numbers on a wall to numbers on your computer screen. This finally changes a little bit with the introduction of the Bloomberg terminal. This happens around the time that electronic exchanges become popular. So electronic exchanges are essentially that you can essentially buy and sell stock without having to be exactly in the place where the exchange was happening, right? And the Bloomberg terminal was the first iteration of a system really with charts and graphs that were interactive for the end user. What's interesting though is if you look at this system, it's quite complicated and it's still around today. And Bloomberg charges its users now about somewhere between $24,000 to $26,000 per seat to use this piece of software that was essentially invented in the early 1980s. And it's so pervasive that the different styles, the styling of the charts, the candlestick charts, for example, that you see here, haven't changed. They're still around today in the original format that they were published in. So what really shook up the market? It turns out it's portals like Yahoo Finance, like MarketWatch, like Google Finance, right? So all of a sudden, instead of having to rely on a centralized source, people themselves could go on the internet and see what was happening at this time. What is the real-time data? And they're not relying on specialists to tell them, I'm going to call and get a number. I'm going to email. I'm going to get a number. They can just look it up themselves. So this kind of starts the democratization of financial data. And it's shocking that it really took so many years for us to get here. And what we want to think about now is, if you think about the past couple of slides, what really has happened is that we started off with data becoming more and more complex, right? We came with just numbers to then with numbers and charts to an electronic system that is so complex that you need a specialized training to look at. But with the democratization of financial data, suddenly your audience changes. So this is no longer something that can only be used by experts, right? We have to think about how do we present data to the average person. At the same time, of course, systems are getting more and more complicated, right? So in really the 2000s, what we're seeing is the development of high-frequency trading. So high-frequency trading, for people who aren't familiar with it, is when you take large sums of money and you move it around very quickly, oftentimes relying on nanoseconds or microseconds with very simple calculations where your distance to actual exchange and the number of feet of wiring can make a huge difference in your profit margin. And with the development of high-frequency trading, what we're actually seeing is more and more complex visualizations. I mean, all right, everyone look at this. Who can tell me what this means? Who didn't work as a trader before? I mean, you can tell there's kind of time on the x-axis, right? The software is really so complex, we have no idea what is happening on the y-axis. And there's no way that someone without specialized training can understand software or a program like this. So all of this really changes in 2011. So in 2011, a company called Quantopian launches. Who's heard of Quantopian? So a couple of you, right? So Quantopian is like a data scientist's dream. You have these skills, you're good at Python, how can I make a ton of money and start my own hedge fund? So what's interesting about Quantopian is it's really the first browser-based algorithmic trading platform. So instead of being focused at professionals, who oftentimes have proprietary systems given to them by their banks. This was for your average Joe sitting at home who may not have the $1 million it takes to actually create trading systems, but who wants to just play around. And so if you compare this user interface with the last one, right, it's kind of a world of difference. It's very easy to understand. The charts are, we're no longer seeing kind of specialized financial charts. They're line charts. Right? There's a clear user interface that kind of subscribes to modern day design, where you have statistics at the top, with risk ratios, and different sections of the interface down the left-hand side. And up until this point, right, what we're seeing is there's kind of this trend of really simple data. Then we're getting more and more data because we're starting to get not just end-of-day quotes, but inter-day data. And the system is getting more and more and more complex. Until 2014, when a company called Robinhood launches. So who's heard of Robinhood or have used it? Wow, that's actually a pretty great percentage. So Robinhood is super interesting because it basically said, we don't care about the extra numbers. We're not going to have any complex fundamentals. We're just going to have a phone app with a super easy to understand user interface. There's just one price. You either click buy or you either click sell. There's almost no way to mess this up. And we're not going to charge anyone any commissions. So trading is essentially going to be free. What's fascinating here, right, is that Robinhood really understood what its user base was. So once again, we're looking at a visualization that is really catering to the lowest common denominator, right? So we strip away all of the complexities, and in many ways, this is just a modern day, price ledger. This is the price, and that's it. And so the question becomes, what's next? Well, there is one more thing that we have yet to do. Up until this point, there was no way to interact with any of the visualizations or any of the tools. You were basically stuck in this one-way world, right? Where we're looking at a chart, we're looking at a list of numbers, but you are simply consuming the information. So last year, this company called Chart IQ launched an app called Technician App. So who's heard of that? Almost no one. Okay, so they're not doing too great with their marketing. So Chart IQ thought, all right, so what's the next stage in data visualization? It's all about interactivity. So what you see here is kind of like a normal candlestick chart that shows, high, low, open, close. What's fascinating about their system is that you can just draw a line and tell the system when the price goes above this line that I've drawn, buy or sell shares. Right? So this to me is way more intuitive than trying to figure out, what's the price I'm going to set in my head. When right now it looks like the price is $578 per share. When I see the average ticker, the kind that you see in Roslyn, all you're seeing is kind of a green up or a red down arrow. Now, how do you know what the history has been, right? So Chart IQ takes everything, turns it on its head and says, we don't care about numbers now. We're just going to let people draw lines in order to trade. So this brings me to kind of a discussion I want to have with all of you. So financial data has been around for a really long time. And at first, it was very simple. And now we're in an era of big data where not only do we have the real-time data, second by second, we also have extra data sources that we can look at, such as sentiment data from news sources, right? Or what you're looking at is stock splits. These are all huge data sets. How do we incorporate that into a system that is used to simple line charts and candlestick charts? How do we incorporate a layer of interactivity, right? And even more complex as we think about it. Before we only designed systems for essentially people who were experts. So we designed them for day traders. We designed them for people who work as actual traders in their jobs. But what happens now that we have brokerage firms that charge low or really no fees, right? What happens when we need the average person to understand? And how does that change our user interface? With that, I'd like to open it up for suggestions, comments, discussions, and questions.
Round of applause. Open it up for 2 questions. We are obviously running behind. Anybody have a question?
I'm in high frequency, actually. You said you're in low frequency. What does that mean? Do you look at financial statements or just daily tickers?
Yeah, so we did a bit of market research and really found that most people who are not in finance basically have 2 investment strategies if you're managing their own investments. So one is you buy some sort of ETF and you leave your money in until you retire. And 2 is you kind of hear like your friend Joe or Bob has like this cool company they heard about, and you buy like a whole bunch of stock in that company, right? And the idea of low frequency is that it's essentially impossible for an average consumer to compete with high frequency firms. But there is a lot of incremental gains to be made beyond today's method of kind of I heard this, I heard that, and kind of going off my gut feeling. That can introduce data-driven methods for the average person.
One more.
I think as far as the next step in getting people to understand this and helping them to trade is incorporating the news into the visualization. Because like if you look up stock tickers, you always go straight to the news. Like even on the Bloomberg terminal, you have the guy on top right who's gonna tell you about it. Like even in like Apple's basic app, you can swipe to the right, you can see some of the numbers like PE ratio and then the news behind it. And whenever I'm looking, I try to connect the news to like what the trading trends were. So like if you ever see Google Trends, it'll say like, okay, there's a major drop or a major rise in activity related to a subject. It'll give you kind of a reason that went along with it. So I think that's the next step.
Yeah, I definitely agree with that. I think natural language processing is essentially going to be the next frontier. Right? We're not going to only work with quantitative data that's already out there, but essentially we're going to create our own data sets.
One more round of applause. Harlan, I think you're next, right? Yeah. Anybody know who this guy is? I picked him up off the street. I'm not sure where he came from. Yeah, there's something about data centers.
All right, everybody. Whoa, this is loud. So I'm Harlan Harris. I want to talk to you today about visualizing set data. And I'm going to talk about 2 particular use cases related to 2 hats that I wear. One of them is that I'm in the data science team at EAB, the Education Advisory Board. We're hiring. And the other thing that I have done is I'm a co-founder of DataVizDC Meetup and Data Community DC, and I want to talk about a specific use case that we've had for visualizing overlapping sets. All right, so the basic problem is that you have data that looks something like this. So you have a whole bunch of people, and they belong to a bunch of sets, or maybe specifically meetups like this one, and you'd like to be able to tell a story about who are the people who are members of or who attend an event for various types of communication. So you're trying to get people a sense of who are the different people in the communities and how do they link together. All right, so this is the type of thing that DC2 has wanted to do and has generated from time to time. And there are a few ways to do it, which I'll show you in a second. At work, we have a very similar issue. So this is a very nitty-gritty problem that we're trying to solve. We have
data that is coming in from our customers, from colleges and universities, and because of some quirks in the way that the data loading process works, we sometimes get incomplete data loads where a particular student should be in all the tables, but isn't for whatever reason. And we'd like to get a sense of, is this a big problem or a little problem, very quickly. We'd like to be able to see this right away. This is exactly the same type of set visualization problem as I described in the previous slide. In fact, I'd even change the names. Right? So almost everybody here, I assume, is familiar with a Venn diagram. If nothing else, you would have seen Drew Conway's really famous data science Venn diagram with hacking skills, math and stats, and substantive expertise. This thing is now like 6 years old, and it's still in everybody's PowerPoint deck. Amazing. So this is a Venn diagram, and just to remind you, a Venn diagram shows you the theoretical overlaps between a set of categories and gives you some sort of description of what the overlap means. It's not a data visualization, it's a conceptual visualization. A very closely related type of diagram is called an Euler diagram. Yes, after that, Euler. And Euler diagrams do show you, in some sense, data. They show you, not conceptually, but in the real world, what does the overlap look like? So I really like this diagram because it's a thing that nobody understands, even if they're from one of these countries, which is the relationship between all the various entities related to the British Isles. So there are a bunch of variations on this, and I don't know how anybody over there makes any sense of this. Anyway, so that's an Euler diagram. This isn't data, so there's no sense in which the Isle of Man is as big as England and Wales, but it's definitely showing you something about the real world. So a closely related version, or a variation of an Euler diagram is called an area proportional Euler diagram. And these things are data-driven, and the insight here is that the size of the circle, or the size of the shape, as well as the size of the overlaps, reflect the actual data in the real world. So if you had drawn those proportional to square miles or population or GDP or whatever in the previous slide, that would be an area proportional Venn diagram. So there's a big problem with these, which is that if you have more than two sets and you're using circles, you can very easily come up with a situation where it is literally impossible to capture the relationships perfectly. The best you can do is approximately. So here's a really simple example of a area proportional Venn diagram with like, what, I don't know, 14 different people or entities that you can't draw perfectly just with circles. So there's green only, red only, blue only. The overlaps, there's no green and blue, there's no red and blue, but somehow there's one person or one whatever that's in all three of the sets. You literally can't draw that because the number of degrees of freedom of the sets is the power set, which grows exponentially, whereas the number of degrees of freedom of your circles is like x, y size, and it's n-1 because one circle is always fixed. So that grows much more slowly, and this is a very common issue. So you'd like to be able to do better with area proportional Venn diagrams. And people have written a number of libraries for doing visualization, calculation of approximate area proportional Euler diagrams. So Leland Wilkinson, who probably most people here know from Grammar of Graphics, wrote a Java app with an R wrapper called Venn Euler, and it will generate nice little approximate Venn diagrams. I'm not going to go into the algorithm. It's a pretty fun brute force algorithm. There's Ben Fredrickson wrote something in JavaScript called Venn.js, does a very similar thing, draws circles, quite nice. There's not a library, but an actual application called Euler APE, which is a Java app that you can use to generate them. They do a nice job if you're making one of these for a research paper or something, or a presentation, but it's not the type of thing that you would do live. And then I wrote a little one in Julia a few years ago called VennEuler.jl, and I'm going to talk about that briefly. So the problem that I was trying to solve, aside from building a fun Julia library, which is a goal in and of itself, is to be able to use shapes with more degrees of freedom. So the system that I set up, in addition to circles, you can also draw squares and triangles and axis parallel rectangles. I have designs at some point to allow you to rotate these, but never actually got around to implementing it. And so this is the code for what it's doing. You create an object with the names which get put on the screen, as well as a data frame that has the membership, just like I showed you before. And then you define, using this like little DSL, the shapes that you want to use. So in this case, I have a circle and a triangle and a rectangle and another rectangle and then a square that I have locked in place. Okay, so a square that I've locked in place, and everything else is free to move to try and optimize the underlying data. And this was for another meetup where I wanted to show some overlap, where there wasn't that much overlap for some of the meetups. So you define the thing, and then you optimize it. And so behind the scenes is moving the circles and triangles and things around to try and make the numbers come as close as possible as you can to an ideal solution, knowing that it is in principle impossible to do so. One note, I would definitely encourage you, if you've been playing around with Julia, to grab my library and to fix it. It doesn't work with the current version of Julia for various reasons. Or some of the demos work, not all of them. So I really like the idea of area proportional Venn diagrams. I think they really communicate something in a compelling manner. If nothing else, the use of bright colors and shapes and things like that are attractive to the eye, I think, and cause people to pay attention to the story that you're trying to tell. So I think that there is a role for them, particularly in cases where you're not hit by the degrees of freedom too badly, as if they're fairly well behaved in some sense. But I think there probably are better ways of visualizations for certain problems where eye-popping graphics are not the most important thing. And just to give you an example of how bad it can go, this is from a paper that was published in Nature that somehow got past their art department. I think this has, anybody have any idea what these Latin names are? I think these are maybe diseases of bananas and showing something about the overlap of their DNA or their proteins or something. Like, this is a nightmare. So this is not area proportional first, right? So this is actually a quantitative Venn diagram. So they drew all possible overlaps and then they put numbers in that. So no idea what's going on. So this is an alternative that I like, and I think this is a few years old. And this is literally what we use at EAB, and I actually quite like it. So this is an upset graph, and it's really simple. All it's doing is, so this is a few years old. This is also the DC2 data, but I think from like 2014 or something. So Data Wranglers was new and so forth. And so the easy thing is the bar graph in the lower left, and this is showing the size of each set. And so there's 4,000 people almost in DSDC and about 1,000 in Data Wranglers, but of course there's some overlap. And then on the right, it has this really easy to interpret indication of what area in the Venn diagram is being referred to by each of these other graphs. So Data Science DC alone, that is people who are only members in this data set of DSDC, is about 2,000. 168 are only in Data Wranglers, but not in anything else. 354 are in DataViz and stats programming, 237 in data science and data visualization. And so, to me, this is a really nice example of a graph that communicates, for one thing, exactly the right answers, right? So these are not approximations of what you're trying to visualize. It's not as visually compelling. It requires more practice to read, but sometimes that's exactly what you want. You want to find a visualization where the goal is to train your users, to train the people who are looking at it, to be familiar with it in a way that, over the last 10 years, newspapers used to put scatter graphs. Now everybody knows how to read a scatter graph, and so newspapers do that. They've trained their readers. So at EAB, we do this literally to do that database table key overlap problem. And so this is actually a pretty good example. So I have no idea what institution this was, but there were 42,000 student IDs. And in almost all cases, the student IDs are in all three. So all the way on the right is 42,047. And then there are a couple of hundred that are not in all three tables. So there's 234 where they're in the table that has the list of majors that they've declared, but there's nothing on the courses or like GPA table. And then there's 137 that are missing the courses. So maybe you care, maybe you don't, but it's very easy if you're seeing a whole lot of these to get a sense of what's going on and whether you need to look into it further. That's all I got. Thanks very much. One thing I missed, so this package is available for R and Python, and it does a whole bunch of things in addition to this that are sort of cool for looking at details, but even the simple version is great. It's very exciting though. Any questions?
You said you want high ups. That does it also work with pandas, or like what is it? What does it also rely on? That's just labs.
I am not totally sure what the interface is for Python. I have not used it. I've only used the R version. But look it up and post it in the meetup comments, and then everybody will know.
One more.
All right, round of applause for Harlan. Thank you.
So I have a question. So when you have charts like this, who do you present it to? You know, is it internal, or is it some person who is just going to look at it without your explanation?
So this one is internal, or not this one. I'm not sure if I would present this chart about meetups publicly for exactly that point. Like the barrier to, it's not hard to read, but somebody has to walk you through it. This one, we use it strictly internally. It's clunky, we're not even changing the names of the tables here. But it's something that, since we're seeing it repeatedly, it's worth the trouble to explain to people what's going on. And then again, it allows them to have a beneficial workflow.
I can't help myself. I want to help answer that question. What do you think about the difference between that and that? Because it's essentially the same chart. That this is a string graph over time.
Right, but it's not showing the overlap. It's showing the total, or maybe it's
the unique, yeah. So that, again, so the unique is equivalent to unique is equivalent to just showing the main things without the overlapping cells. And if most of your data is unique, I think that's fine. It just depends what you're communicating.
Yeah. It's pretty.
Question back?
So I'm just wondering, showing the similar stories of the instances, we use the bar chart, but with a stacked bar chart, and
so the question is stacked bar charts.
And the color represents their overlapping relation.
Yeah, I think there's ways to do it. You're going to run out of colors pretty quickly that are different. So this thing works. You know, this is I intentionally cut this one off at 10 different bars. If you look at all combinations, it's whatever 2 to the 6th, 32, I guess. And you know, you get a little bit of additional information there. Again, this is, if you want to know exactly what's going on, I think a particularly good option.
Well, that's our applause. DataVizDC is up next, and she has 20 helping roles, and you guys switch back and forth.
Hi, everybody. That wasn't good enough. Hi, everybody. Hi. I think you guys can hear me, right? Yeah. All right. What's up? aesthetics, and while you guys' slides were excellent, I believe that slides go under a microscope, so I only have 4 slides. I'm going to do a demonstration. And I'm going to talk a little bit about an app that I created that got put in the R Shiny User Showcase. Now, the Shiny User Showcase is pretty awesome. These are all Shiny apps that users of R have created. These are amazing. I created one to try and study GDOT. How many people have heard of GDOT? Cool, a couple people, awesome. So GDOT is a database, basically, of journalistic of events that have been cataloged in some journalistic effort. These journalistic efforts range for 100 different languages all over the world. And they're events that have happened from January 1st, 1979 on. And so GDOT just happened to be one of the first databases that got put in Google BigQuery. How many people know about Google BigQuery? Oh, awesome, more people. So I created an app, and because I'm a network scientist, I see everything as things that are connected to other things. I created an app that looks at connections between countries in GDOT. And so this is an app that anybody can use. And so we're gonna play with it. Okay. So if you use Google BigQuery, you're probably one of the Google developers. And so you have a Google developer account. Anybody can have a Google developer account. And so I'm going to put in my information for my Google developer account. Now, the way this works is in the GDOT database, each event has a date and actors can be countries. And so I wanted to look at how the countries connect to each other based on events. And so we're going to select March 22nd for our date. And my project ID and I'm required. No. Okay. So, if you have a Google developer account, or if you have a Google account, you can create a Google developer account and you can get this information. All of the instructions for getting that information is all up here on the app. And so now we're going to look at how the countries are connected. How the countries are connected via events on March 23rd of this year. Now, anybody remember what happened on March 22nd of this year? That would be the Belgium attacks, right? All right, so shouldn't be. Okay, sorry. This is what happens when you go live demo. However, so what you will see is a picture of the network of countries connecting to each other based on events.
You might want to see if you have a space before your project ID and client ID.
I'm going to give me a, this doesn't match your Google information.
Yeah, there's a pop-up and I got blocked and trying to remember why I didn't have a plan to do that. So just in the settings, I think.
Okay. Well, what we would have seen was a picture of a network. And a network is a group of things that are connected to each other, and all the dots in this network would be countries. What we would have seen is that Belgium would have been right in the middle because of it being March 22nd data, but it would have looked like a hairball. And so if you click on one of the countries, one of the dots, you can get the neighborhood of that dot. So the neighborhood of that country, the countries that connected to it via events. And so what happens is that particular country turns red, that dot turns red, and then all of the dots that are connected to it turn yellow. And then you can scroll down and there's a beautiful map that shows up that is the country in red and all of the countries that it connects to in yellow. Sometimes the country is right in the middle of all of its neighboring countries geographically, and sometimes it's not. Which is super cool to see.
Right.
Everybody, next time you see one of those Stargate SG-1 episodes where they, under fire, connect to the alien technology they just found out about 5 minutes beforehand, use alligator clips to connect to the front of an ancient building, somehow decipher code into that, like within 5 minutes while their, Apophis is coming in the ship. Next time somebody says that computers are taking over, just artificial intelligence is not a threat.
So about that wall.
That's my code. So we sound it's a yellow from
Okay, so as you can see, Belgium is right in the middle, BEL. And we can click on Belgium. And this is red. And everybody's talking about Belgium. And we can scroll down a little bit. And get a list of all the countries that it's talking to via events. See you there now? Where Belgium's in red and all of the countries that are connected to it are in yellow. Now the other thing that we can do is we can look at how the densely connected network. So we can look at just the other countries that are mentioned in Belgium a lot. We can change the weight to 471, which means 471 events that these two countries have to be a part of. becoming a smaller network. This network is plotted with Sigma.js. And part of the cool, one of the features of this app is that you can right click on the figure and download a PNG of it. So you can have it for later. The other cool thing that you can do with this app is you can download data. You can download it as an R data worksheet. So you can then play with your graph later and more. So I'm going to go back to the slides.
This is random text. Read it.
All right, last but certainly not least, Jackie and I co-founded Women Data Scientists DC. And so if you're a woman in data science, if you're a woman who wants to be in data science, or if you're a supporter of women in data science, which should be the whole room, you're welcome to join Women Data Scientists DC. Thank you very much.
Couple questions? Alex.
That was awesome. It just seems like an amazing amount of work before you even get to the network graphing side. So I can understand like there are parts of that there's tons of technical limitations. But I guess my question is, have you considered stuff like I don't know, coloring by degree, or I just wonder also if these issues where I feel like the total number of news articles has to be increasing over time.
Oh, it absolutely is. That's why you give it a date range.
So is there a way to weight maybe find like, so maybe a small country has a strong connection with Belgium, but because they have a smaller number of news written about, you see what I'm saying?
I do.
Issues there too?
Absolutely. These are all things that I have thought about. This particular project was done when I was at L3 Data Tactics, as you can see by the logo at the top, and I'm currently now at CyberX. But it is available on GitHub, and so anyone can download it and use the code. I did color by degree to begin with. It ended up being a huge mess of colors, and there weren't enough colors to dictate on the degrees. And I also colored by, I did reweight based on the total edge weight. And that didn't end up giving me that much better a picture in Sigma. So, but all really, really great ideas.
Okay.
Anybody else?
How long did this take you to build?
So to build the original app, it took me about a month. To jazz it up with JavaScript, it took me about another month.
And that's full-time, 40 hours a week, 2 months.
Oh, no, that's in my spare time. A month. And a month.
That's because she's awesome. One more round of applause. And last but not least, we have Bill Rapp. Close that so that my computer doesn't crash. It's working. So there we go.
All right. Hello. So I recently published an article in the Medium about maximizing the impact of data visualization work. And what prompted me to write the article, and I think what I was thinking about was, I've been around in data visualization for a few years now, and over the last 3 or 4 years, there's been such an explosion in interest in data visualization. And there's also been an accompanying explosion in technology and conversations and theories and meetups and books and buzzwords that, and tools that it's a little bit overwhelming sometimes for a data visualizer to kind of digest all this stuff. And don't get me wrong, I love all that stuff. I consume it, I enjoy it. I think it's a really good, positive thing. But I think it's easy for a data visualizer to maybe get distracted or overwhelmed by all of it, and maybe lose track or lose sight of some of the aspects of data visualization that will be most determinant of success or failure. The aspects that will potentially deliver the most impact for your work. So I think the best way to frame this whole conversation and to show you where I'm coming from on it is to talk about my history in the field and where I'm coming from, my perspective on data visualization, because I'm sure a lot of you here are coming from different places. But I've been a professional graphic designer for more than 20 years, so I think of it, I approach it from the design standpoint. And over most of the last 10 years, I was employed by a small startup public policy think tank called Third Way. And for those of you who don't know what a think tank is or what it does, it is a group of people who come up with ostensibly smart public policy ideas and messaging to communicate these ideas to a very specific target audience, which is policymakers and people who influence policy in the United States. So that was kind of a cool place to be as a data visualizer or as a graphic designer first. And I want to tell you how I kind of moved into data visualization by showing you some of the early work that I did there. So rewind to 2009, which is kind of the stone age of data visualization. And so this is an information graphic that I did back in 2009 to illustrate the imbalance in investment in clean energy and the potential payoff of economic payoff, besides saving the planet, of investing in clean energy, and whoever leads in clean energy technology can really cash in on saving the world, if you will. So I'm just going to kind of fly through a couple of these things. You'll get a sense of them. This one is on Social Security, and the idea is we're cruising along in a surplus, but we don't really see the waterfall that's ahead if we don't make some changes in how Social Security is administered. Here's one on relationship recognition and gay marriage. We did a lot of work on that and the changing attitudes since, in this case, DOMA. This one is about debt ceiling debates and the consequences of defaulting on the US debt. This one was in support of the Manchin-Toomey gun laws, which would plug some of the gaping holes in the current system that allow people to, anyone, in this case, this example, felons, to buy guns, no questions asked, with no background check. So it's plugging some of those leaks. Now, I want to put these into context because these are from a number of years ago. In 2009, when I started doing visualization work, I came to it organically. So I was in a think tank, I was a graphic designer. The idea was, how do we get these public policy ideas out? How do we make them resonate with the people that matter? And how do we do it efficiently? Because previously, the method of delivery was a 20-page report in PDF. And there were dozens, if not thousands, of similar reports flooding congressional offices and staffers and so forth. So naturally, I thought there's got to be a better way to communicate these ideas, and I started experimenting, and those were the kinds of things that I came up with. In 2009, here are some phrases that I had no familiarity with whatsoever. Data visualization, never heard. Infographic, I think, actually, I'm a little embarrassed to say, but probably the way I first heard the word infographic was somebody said, "Hey, I love your infographics." And I said, "Thanks, I appreciate that." And then I Googled infographic. And I said, "Oh, well, I guess that's what those are." Statistics, of course, I've heard about statistics, mainly from maybe college friends who said, whatever you do, don't take a statistics course. Or I'm taking a statistics course and now I want to kill myself. So I knew to steer clear of statistics, and I still, to this day, only learn it grudgingly, but it's a part of the field, so it's pretty unavoidable. Data science, data to ink ratio, storytelling with data. I mean, what would somebody say if you said storytelling with data in 2009? There's not many people that would know what that meant or what you're talking about. Here's some more things. Some of these things didn't exist in 2009, but I'm just trying to make the point that there are a lot of new ideas and concepts and technology that you have to grapple with, you have to understand if you're going to be doing data visualization these days, which I was blissfully unencumbered by back in the day when I started to do this kind of work. Now, I think that was an advantage in the long run because the phrases I was familiar with were these. Because at this particular think tank, we talked about these things all the time. These were core values. These were core things that we had to focus on in all the work that we did there, and that extended to data visualization and these information graphics that we did. So target audience for a think tank in public policy is pretty clear. It's congressional staff at the center of the bullseye, and then there are other targets outside of that, DC influentials and other policymakers, and there's a wide variety of audiences, the press, and the general public, but you want to kind of zero in on your target audience, and with public policy, you know who those people are who are writing the legislation. Goals, you know, one of the things that was a favorite saying at the think tank was, don't be your own audience. So don't just do things because you think it's a good idea. Do things that are going to move the needle and that are going to make progress on these issues. That was always, things had to be very clearly purposeful. And so there were very specifically articulated goals for each project that we undertook. So each one of those graphics that you saw had a particular angle. It wasn't just do a climate change graphic. It was about the economic impact or factors around climate change. So those are things that we really focused on and looked at. And then impact, and that can mean different things to different people. For some people, impact is page views, or impact is getting a lot of compliments on how cool your data visualization looks. And so this talk and this kind of work is, and this kind of idea is really not for those people. They have different priorities. So we did get a lot of traction because not a lot of people were doing visualization type work in general, and very few in the DC area. We got picked up by a lot of national media, and we got a lot of exposure. A lot of that work was distributed to the Democratic caucus and the leadership and committee members, and so we got a lot of traction with this work. And even though it was a very relatively small boutique think tank, and after just 8 years of existence, we won the 2013 North American Think Tank of the Year award, which was pretty stunning. And I think, you know, it wasn't because we were doing data visualization exclusively, certainly, but I think that was a significant factor because we were communicating ideas in a really new, innovative way. And so I think this just shows you the power behind communicating using visualization. And I'll tell you that even more stunning, the behemoth the king, the granddaddy of all think tanks, Brookings, was second place in this competition. And they had been around for almost 100 years. And so that was pretty stunning even to us. And on that note, I just wanted to share with you, Brookings is celebrating their 100th anniversary, their centenary, and they developed a logo for that. And I wanted to share it with you all because I think you'd appreciate it. I didn't make that up, that's real. That's actually their logo for their centenary. So I think data visualization has officially arrived in DC. If it hadn't already, that's pretty amazing. I'm just going to circle back to the article. In the article, I talk about a journey and how charting the journey is just as important as charting the data. And when I talk about a journey, I'm talking about a metaphorical journey. You may have noticed that I'm pretty fond of metaphors and analogies, and I use them in my work. But the journey that I'm talking about is connecting 2 points and making that into a journey. So point A and point B. Point A is your primary target audience. So you need to know who your audience is. You also need to know as much about them as you possibly can. Now, you might not have a ton of resources, so it might be very limited what you can learn about your target audience, but learn as much as you can about them because that is very critical. Now, a lot of people think, well, I want it to be I want it to have broad appeal. But I think even then, you need to narrow it down and zero in on a certain type of demographic. Maybe think of an individual person who, a favorite college professor, or if you want it to be very broad, you might say, well, I want my grandmother to be able to read this graphic, or my 5-year-old daughter. So as much as you can, focus in on a primary audience. You can have secondary and tertiary audiences also, but your primary audience is very critical, and the more you know about them, the greater your advantage in doing data visualization work. Point B is your organizational or your project goals. Quite often your organization has broad goals, and then you do a project and it has very specific goals. The more specific those goals are, the more specifically they are articulated, and the more clearly they are articulated, the greater advantage you have. And also defining what is impact for you. What are your goals for this project? What do you want to see happen? And it can be multiple things. Connecting those 2 dots is where all of your data viz design happens. So every decision you make about the form that you choose, colors potentially, every single decision that you make is now filtered through this information you have about point A and point B and connecting them. You want to pick up your audience at point A and you want to bring them to point B, which is your goals and your destination for the data visualization. If you don't have those 2 points, then I can't for the life of me tell you what you would use to make decisions about what you're designing. The only thing I can think of beyond arbitrarily choosing one thing over the other is what would look cool. And that's not really a recipe for impact. So target audience. You can do a really cool piece of work, but it might not fly with a given audience. I just wanted to throw this in here because I thought it was funny. But my point is that, some people go into a visualization thinking about the forms before they think about the audience. And so I think you really have to know who you're designing for before you embark on doing any visualization work. This is the example from the article, and I posted it because it gives a very clear example of what I'm talking about. This was an assignment that was given to me during my graduate program at MICA, and we have some MICA in the house here somewhere. Shay, where are you? There it is. one of my classmates is here, he got this assignment as well. But it was to create an information graphic for Kenyan school children to help, who don't necessarily understand English very well, to help them understand how the environment and the animals that they see every day where they live are part of an interconnected system and an ecosystem. And so not too heavy on language, make it playful, colorful, and so I created this thing called a bite chart to show how all the different types of animals feed on one another and how it all fits together as one system. But the assignment really handed us point A and point B on a silver platter, right? The target audience is Kenyan school children, and there's more information on them. They don't speak English very well. They live in the grasslands, so they see these animals and they see these plants and they see this ecosystem every day, but they might not understand how it's connected. So that's a lot of great information. And then what are the goals? To teach them that it is an interconnected system, to give them vocabulary words like ecosystem and grassland biome. So some people might look at that and say, well, those are constraints on what I want to do. But I think it empowers you to such a great extent, because then you can really focus on what you're trying to accomplish, who you're talking to, and every decision can be answered by what you understand about those two things. I'm just going to bookend this conversation by showing you a little bit of my more recent work. Some of these are assignments and some of them are other pieces of work that I did, but this is a map that illustrates how to use these bike boulevards that they're putting in Arlington, Virginia, how they run parallel to the main artery so that you don't get a lot of bike traffic mixed in with the regular traffic. As you can see, more higher data to ink ratio, a little cleaner, but I tried to bring forward those same principles. Who are we talking to? How can we make it clearer and simpler? I stripped out all kinds of roads and all kinds of information to focus on what's important and what would make something like this useful to someone learning about what bike boulevards are. This is a piece I did on international trade and trade deals, a little more technical and focused at a more technical audience that would understand some of this stuff, but there's a heat map that shows before and after the trade deals are implemented and whether they produced surpluses or deficits. There's a slope chart that is fairly redundant to that and shows the information in a different way. And then there's some small multiples. And this is a piece that I'm doing on SIDS and SUID, that sudden infant death syndrome, and sudden unexpected infant death. And this is a connected scatter plot which shows a great deal of progress in safe sleep environment and a dropping death rate, and then a stagnation of progress as of 1998 or 1999. So this is designed to bring attention to this issue and explain it to probably a more sophisticated audience, pediatricians, public health officials, children's health officials, that sort of thing. So this is the kind of work and kind of evolution that I've experienced. But I think the point is that the same principles that guided those early information graphics and infographics are guiding this work. It's exactly the same set of principles. So embrace the journey and enjoy the journey. Thank you.
Before we go to questions, anybody here have an index card that they're going to tweet out?
I got one, which means that Sophie is going to win unless somebody else wins. We'll tweet it out, we'll show it in a minute. Any questions for Bill?
My phone is dead.
Your phone? Phone is not dead, come on.
You have an iPhone?
Use somebody else's phone.
I have a battery.
Any questions?
I can actually tweet it for you. Sorry.
How many dollars designed with data presentation efficiency?
Well, design is largely problem solving, and again, I think if you approach a project looking at those factors that I was talking about, the point A and the point B, if you know your target audience, that helps you cut down on a lot of superfluous information and can help you be a lot more efficient because you know exactly who you're talking to. Now, that doesn't mean that other people can't consume it, okay? It can be very broadly appealing, but you really want to be focusing on a particular type of audience, and that will help you to be very, very efficient. And then also, in terms of your goals, you don't just say, well, I'm going to do a visualization about Syria. You know, you really have to go further than that and apply some editorial decision-making to your project and cut down and say, what do you want to talk about in terms of Syria? There's so much to talk about. So again, that makes you a lot more efficient. So ideally, you will come up with something that is, through the design process, that is extremely efficient and is extremely elegant. You're going to be looking for the most elegant solution. So I think that is a natural progression, and it is entirely, if people know what they're doing, I think the expectation should be that you get a very elegant and efficient end product.
I really liked your work with think tanks, so third way, and then what you showed with Brookings. I got the question around impact in terms of goals and impact. I imagine you get, in terms of your work, how do you measure impact? So if a client comes to you and says, we'll spend X number of dollars, how do we know that we're getting their return? How can you measure that? How do you answer that question?
Yeah, that's an excellent question. That's a question that was asked all through my tenure at the think tank and is probably still being asked. Because it's a moving target and it is many things. So I think you look for evidence of impact. And so when somebody says, you know, you won the North American Think Tank of the Year, you know, that's not impact in and of itself, but it's some evidence of impact. It's somebody saying, hey, these guys are doing something really well and really meaningful. And so many people track impact by page views and by hits, and you know, just are looking at raw analytics, which also is not impact. But I think you know, occasionally you have a situation where a piece of legislation actually gets passed or it gets presented in debating, and that's evidence of impact certainly, but that's rare. So a lot of times it's about steering the conversation. It's about having, when you put ideas out and then the president says them in a speech, that's impact. Or a member of Congress raises something that you presented or gave them on the floor of the Senate, let's say, that could potentially be impact. Press placement in the New York Times and some major publications, evidence of impact, but you know, so it is a very difficult thing to measure, and there is no hard and fast rule for it. There's a lot of ways that you can sort of see evidence of it. Does that answer your question? Yes?
First of all, a compliment. I think you're amazing. Being able to tell the stories the way you did with data in ways that we data scientists, who I don't think of myself as an artist, would never come up with. So, very well done. The other thing I'm going to talk about as a data scientist, I love looking at some data and drawing conclusions. And what you are doing is more telling a story based on the work you've already done. So the issue is, how can you meld the two of them where your audience not only sees the story that you're telling, but also has the sense of discovery of looking at it and sees, oh, I draw something from that, whereas you probably draw a conclusion because you want to tell a story. That's kind of stream of consciousness, but I think we're actually looking at two very different things here.
Yeah, I mean, I think, you know, one of the buzzwords that gets thrown around a lot is storytelling. And I think it's a good one, but I think that if pressed, a lot of data visualizers and a lot of other people probably couldn't really tell you what that means. Because storytelling to most people means a linear narrative, right? Story. And that's not always really what you're doing with, you know, a connected scatter plot, let's say. I think part of storytelling for me is connecting with things that are already in the reader and finding things. And you see that a lot in my early work where I'm using metaphors, because everybody knows when you tip one domino, the rest of the dominoes fall. And everyone knows, you know, what casino chips are, and all of these things are sort of already in people. So it's hard enough to communicate when you're giving somebody a chart form and they have to learn how to use it. You have to tell them how do you decode this. I like to try to find ways that you can tap into what's already in the person, because that shortcuts so much, and it's much more powerful if they're finding the story that's already inside them. So there's no easy way to do that. You just have to look for that, and you have to use all the tools at your disposal. You know, the title, the accompanying text, the annotation. You have to come up with a form that makes sense to people, that's intuitive. So I think you're teasing that out all the time. Does that help answer your question?
It kind of does. I've never seen work like yours as well presented as I have tonight, and I'm just trying to put it all together.
Thanks for coming, Brad. So I'm going to give Sophia a chance here to talk about it. She's being shy, yet she's one of the, she helps organize DVDC.
Hi. So I've never really done this before. You just have people talk through the visualization review.
I mean, yeah, so it looks like.
It speaks itself, right?
Which one was the first talk? So G-Delta is obviously the third talk.
Information was the first.
The overlapping is the top right. So we went from left to right, down and over.
I didn't really, yeah. There was no method to that.
You've got the squiggly line down on the bottom right where that was showing the infant deaths.
Yeah, that's right.
And then the bikes were one right next to each other.
Yeah, you can figure out how to draw a bike really quick.
Yeah, we've got two wheels in the seat, right? And you can see that it's separated from the main road. Then you've got the chopping, right?
Yeah, the Africa Kenya students.
The target to goal, right?
And it was hard to mimic the amazing infographics, or however way you want to describe your visualizations, but those were really nice and made it hard to visualize
around the world that turns into a hairball. Harlan's chart, along with the triangles and everything like that. This is pretty cool. One more round of applause. Everybody, thank you very much. There are actually beers outside if you're feeling thirsty, and I think there's still a little bit of food out there, so you don't have to run away. You can go home. You can stay for a little while. We still got, I think, another 20 minutes, half an hour before they start closing the doors. And please don't forget to talk to Tom about the jobs. Thank you very much for coming.